Hey folks, second week of completing the square. Let's go. So at the top of the screen there, you've got the familiar formula from last week. If you haven't seen that, I'd recommend going and watching it first, otherwise this is going to make no sense whatsoever. And all we're going to do is we're going to apply this completing the square idea to when the number in front is not x squared. So for example, here it is 2x squared. Now, a tempting thing to do here would be to divide by 2, but we don't want to change the value of the actual square completion. So we have to keep that 2 somewhere, and we're actually going to take it out as a factor. We're going to say that what we've got here is 2 lots of x squared plus 8x. I'm actually going to go over to the side here and complete the square with x squared plus 8x. That would be x plus 4, because we need to halve the 8. Take away 4 squared, so take away 16. So once I figure that out, I can sub that in. Instead of the x squared plus 8x, I can say I've got 2 lots of x plus 4 all squared minus 16. So I'm kind of working out the completing the square and then subbing it back in. And then what can we do with this? Well, we've got 2 lots of this, so we're actually going to expand this bracket. We're going to multiply 2 by that, and we're going to multiply 2 by that. So 2 times the bracket, you could expand it, but then what's the point? You've completed the square for a reason. Will be 2 lots of x plus 4 all squared, and 2 lots of 16 will give you minus 32, and that's it. That's as far as you need to go. So our 3 steps there were to take out a factor, were to complete the square with what's inside the brackets, and then to multiply it out. So we want to take out a factor, complete the square, and then multiply out. So let's try this with the other 3. You're perfectly welcome to pause at this point, but I'm going to crack on. Let's take out a factor, 3. Let's complete the square. So that would be x minus, let's stick with fractions, shall we? And then let's substitute that back in. And then let's expand that. 27 over 4, I guess. You could also have 6.75 there if you prefer decimals. Yeah, that's it. Okay, let's do it again. Take out a factor. Let's do decimals this time. Let's complete the square. And then let's substitute that back in. And expand. What's that? 2.25, I think. Okay, and then one last one. Let's do fractions this time. Take out a factor, 10 this time. We're always trying to make it 1x squared, because that's the only thing that we've actually got a completing the square rule for. Let's complete the square with this. So half of that would be 17 over 20, and then take away okay, and then let's substitute that back in. And then let's expand it. Cool. Now, those last 2 questions are probably as tough as you could possibly get asked in a GCSE context, but certainly make sure that you're happy with the first 2. I think those are ones that you could see. Bear in mind that if there's other stuff, you kind of want to ignore it for a bit. So we've got this plus 35 here that we didn't have on the previous page. We're going to completely ignore that. We're just going to complete the square with a 3x squared plus 12x. So we'll take out our factor again. And then we'll complete the square with that. So x squared plus 4x, that goes to x plus 2 all squared, so half that to get 2, take away 2 squared, so take away 4. And then we'll sub this back in, and then we'll remember that we've got this plus 35 to think about as well. So we've got 3 lots of x plus 2 all squared, take away 4, plus 35, and then let's expand that. So we'll do 3 lots of the bracket and then 3 lots of 4 for the minus 12. And we've still got this plus 35 that we've done nothing with. And now finally, we'll bring those two things together. We'll say we've got 3 lots of x plus 2 all squared plus 23. So you just you ignore it and you factor it in at the end. So similarly here, we'd ignore this plus 16 for most of what we're going to do. We'll have 5 lots of x squared minus 6x this time, plus 16. We'll complete the square with that, so x squared minus 6x, that's x minus 3 all squared minus 9. Again, halve the 6, and remember to keep the sign as being negative inside the bracket. Substitute that back in, and then expand that. So we'll have 5 lots of x minus 3 all squared minus 45, because we're doing 5 times 9 there, plus 16. And that would give us 5 lots of x minus 3 all squared, and that would go to overall minus 29. Cool. Now, a pretty big word of warning here. You might get a question like this, and it might say completing the square. And at this point you think, well, okay, well, there's more than 1x squared, so I'll take out my factor and I'll start working stuff out. But for equations, the rules are slightly different. For equations, you can divide both sides, and it's fine. You don't have to keep that 3 as a factor. So all I'm going to do is divide both sides of this by 3. I'm going to end up with x squared plus 6x plus 3 equals 0. And I can just use that. I don't need to keep that 3 hanging around. That's only when the value needs to be maintained, as it did on the previous slides. So we'll complete the square with this. We've got x plus 3 all squared, take away 9, plus 3 equals 0. Plus 3 is coming from there, obviously. We would then bring our 9 and our 6 together, so that would be minus 6 is 0. Add that to the other side, square root, and don't forget the plus or minus when you do square root, and then subtract the 3 as well. Now, does that give the same answer as if you took out the factor of 3? Yeah. And there's what it would look like, but that is way more complicated, way more messy than the way we did it first. So I would recommend very much that if you have an equation and it says completing the square, just divide straight away. Okay? So bearing that in mind, I'd like you to have a go at these two, assuming you're pausing the video now. And let's get going. So remember, we need to divide everything before we start. So we're going to start by dividing this one by 4. This will give me x squared, and 4x minus 2 is 0. I can then complete the square with this. And don't forget the minus 2 at the end. I can then combine those two things together. I can then add the 6. Oh, it's another 6. Square root, and take away the 2. With the other one, a little bit more complicated because we're going to have some decimals involved now. But we start by dividing by 2. And notice I don't even need to bring the 5 over, really. But you do have to divide everything by 2, so that 5 needs to be divided by 2. And then complete the square, so that's going to be x minus, what should we use? Let's use decimals. 3.5 squared minus 12.25 is equal to 2.5. And then it's the same as what we did last week, so we're going to add the 12.25 across. We are going to need to square root that. Don't forget the plus or minus. And then we're going to need to add the 3.5. Absolutely horrible looking, but yeah, that's how we do it. Now, as far as pure difficulty of equation goes, that's as hard as GCSE is going to get. And to be honest, even A-level is not going to push you much further as far as completing the square goes. But there is one more type of question that they do like at GCSE, which is the equivalence question, which is ones where they've got this old triple equals sign. This is called an identity symbol, and what it means is that the left-hand side is always the same as the right-hand side. So no matter what value of x is, they're the same. And you'll often get something like this, where it says left-hand side is equal to right-hand side, find the sort of the missing numbers. And I think this is something that we've struggled with when it's come up in the past. So I want to talk through a few completing the square examples of how we do this. And generally you want to approach these by like expanding things that you can expand, and then just comparing stuff. So in this example here, the only thing I can really expand is this x plus 4 all squared. Remember, if you've got an x plus 4 all squared, that means that's an x plus 4 bracket times another x plus 4 bracket. And so if we multiply that out using the claw, we'll have ourselves an x squared and a 4x and a 4x and a 16. So overall x squared plus 8x plus 16. Okay, we're going to use that. So let's expand that and let's write what we've got. So we've got x squared plus ax plus 23 is equal to x squared plus 8x plus 16 plus b. So what we want to do is we want to compare. We want to compare things that are of the same power. So we're going to compare the x squareds to start with. And if we take just the x squareds part of that equation, it'll tell us that x squared is equal, so we should use the triple equals here, equal to x squared. And that's true, and there's nothing we can really do with that. Okay, great. What else could we have compared? We could have compared the x's. Now on the left hand side we have got ax, you can see that there. And on the right hand side we have got 8x, and there's also a 16 and a b, but yeah, they haven't got x attached to them. What does that tell us? If ax is equal to 8x, that just tells us that a equals 8. So that's one of the problems solved. Okay, so we compared the x squared, we compared the x's. What else could we do? We could compare, I guess we call it the rest, but we'll say compare the numbers. Now on the left hand side, the only number is 23. And on the right hand side, we've got 16 plus b. So what does that mean that b is? Well, 16 plus 7 is 23. So b equals 7. And there we go. So expand what you can, and then compare the different powers to each other separately. And that's how we find a and b. So here's another example like that. You can see here that we've got, again, something that looks like completing the square, but our first step is going to be to just expand everything, and then we can see what we can do. The only thing we can expand is this x minus 5 squared bracket. I'm going to do it off to the side. That would be the same as x minus 5 times x minus 5. And if we multiply everything out, that will give us x squared minus 5x minus 5x plus 25. It'll give us x squared minus 10x plus 25. So that's what we're going to use. So expanding that gives us x squared plus ax plus b triple equals x squared minus 10x plus 25 minus a. Okay, let's do the same thing we did before. We're going to compare. So we could start by comparing x squared, but as with the previous situation, that doesn't actually tell us much. X squared equals x squared. Well done. So let's compare our x's, and that would give us that ax on the left hand side is the same as minus 10x on the right hand side. And what would that tell you? That would tell you that a is equal to minus 10. And then what's left? Well, we can compare the numbers, and hopefully this will tell us what b is. So on the left hand side we've got b, and on the right hand side we have got 25, positive 25, minus a. Now we know that a is equal to minus 10, so we can get from that that b is equal to 25 minus 10. Now minus minus is a plus, so that tells us that b is equal to 35. And that's it. So yeah, the tricky questions they can give you in GCSE, I think, are using these sort of identities with completing the square. Now, for the sort of grade 8-9 thing with a side of explanation, they can ask you to explain why something is always positive. And this is, again, something we can use completing the square to do. In fact, it's one of its main uses is with sketching quadratic graphs a little bit later on, and we use this to sort of find a turning point. But we'll come to that in chapter 17, I think. 17, 18, one of them. So, explain why this is always positive, and we're going to do it by completing the square. So, we'll do that. X squared minus 12x, that goes to x minus 6, halve it, squared, take away 6 squared. Don't forget we've got a plus 50 on the end there as well. There's no equals here, so we're not going to solve this. We're just going to sort of simplify and see what we've got. So we have got x minus 6 squared plus 14. We can't really go any simpler than that. If we expand it, we'll just be back where we started. So why is this always positive? Well, this is the key. So this is a square number because it is x minus 6 squared. And one thing we know about square numbers is that they are always positive. Is that true? Well, okay, 3 squared is 9, great. Minus 2 squared, minus times a minus is positive, yeah. If the number was positive, then if we square we get a positive number. If the number was negative, we square it, we get a positive number as well. So square numbers are always positive. So what has this become? This has become a square number plus 14. It has become a positive number plus a positive number. So if you have a positive number and you add another positive number to it, you will get a positive number. So that's it. That's all we need to say. We show what it simplifies to, and we say these are both positive numbers, so their sum must be positive as well. We couldn't do that straight at the start because it was a positive, x squared, take away something, plus something, so it might depend on x. Here we've shown that doesn't matter. And the last sort of version of that question is here. What is the minimum value of y equals x squared minus 6x minus 9? And again, what we're going to do is we're going to complete the square with this. So x minus 3 all squared, take away 9, and then don't forget we've got another take away 9 here. So simplifying that would give us that y is equal to x minus 3 all squared, take away 18. And what have we got here? We've got a square number minus 18. So we wouldn't be able to show that this is always positive, for example. It could definitely be negative. What's the smallest it could be? Well, what's the smallest a square number can be? So is it 1 squared? Well, 1 squared is 1. That's pretty small. Is it a half squared? If you do a half times a half, you actually get a quarter. That's pretty small. Now, the smallest square number that exists is 0 squared is 0. So the smallest that this could be would be 0, and that happens when x equals 3 to be precise. So if we're saying what's the smallest this could be overall, well, it would have to be at least 0 minus 18. So y is at least, obviously the value of 18 isn't going to change, 0 minus 18. Now what is 0 minus 18? It's minus 18. So the minimum value is minus 18. So that's again using that all squares are positive things to answer a slightly different question. And that's all we've got time for this week.